Aaron Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Happy Saturday. It's not Saturday. Come on, man. Get with it. Happy Friday night to you. It's almost Saturday. We've got a couple hours left of the day. Thanks for joining me, Meteorologist Aaron Tuttle. My brain is on Saturday is the problem. I've been looking at data here for all day for tomorrow. So just had to see what the latest was before we started our broadcast here for tonight. So thanks for joining me out there on Twitter, X, Rumble, Facebook, and YouTube. Put some information in the comments section on the platforms there where you can do a little following to get some notifications if you're having some trouble in that department also. So what we're going to do is kind of focus on what's going to happen here for our weekend, and specifically for the first part. Second part's not too bad. It's we will see some storms on Sunday across basically the eastern third of Oklahoma. Otherwise, the rest of the state looks good for Sunday. And actually, most of your Saturday looks good too. It'll be quiet for most of Saturday, so that's good. It won't be until late afternoon and evening where we have to start to worry about, the dumb stuff. So, tornadoes, for example. So, looks like most people are piled on in, and we'll still get some stragglers coming in probably in the next few minutes. So, welcome for everybody who's new, never been here before. So, we're going to dive a deep dive into the meteorological data to find out what's going to be happening across your area. All right, I think I got all that stuff out of the way. Take a quick look here at the radar. We did have, believe it or not, 2 tornado-warned storms today. One was way down here, and it was south of Ardmore, south of Marietta, and it was around Thackerville. So there was a mid-level circulation on radar. I didn't see any comments of or reports of tornadoes, which is good, and they let the warning expire right after it was issued. So they didn't keep it going, so that's all good news. And then we had this other storm here that's still ongoing. It also had a tornado warning part of it a couple of hours ago. Again, very weak circulation. I did not see any confirmation on the ground. There was a wall cloud with it when it was up here around, was it Marble City? Yeah, between Marble City and Paradise Hill. But right now it's much smaller, much weaker, small hail, etc. So that's it. Otherwise, quiet here for the remainder of tonight. In Oklahoma, all the storms have moved off into southern Arkansas. They're just severe hail, wind, and some lightning. And then down here in the North Texas, they had a lot of storms, a lot of hail reports in and around the Dallas-Fort Worth area. All these little icons you see here on the map just indicates where you had hail reports that came in, and so they were various sizes. And then all that stuff is now down here into far eastern Texas. Did have one tornado warning with this one. This storm was left of it when it was back around, how was it, south of Canton? I think it's back toward Kaufman, somewhere in that area. So not too far from Dallas. All right, well, that's it as far as what's happening out there currently. Then tomorrow is a brand new day. So let's take a look at what our brand new day entails. By the way, today was hot, especially in southern Oklahoma. Still some 90s down here with the humidity. So obviously that kind of helped to fire off those thunderstorms. Whereas really, if you were basically along this line right here and northwest of it, you had much dry air and temperatures topped out into low to mid 80s. So much different atmosphere in the northwestern 2/3 of the state versus the southeastern 1/3. Ended up being a pretty nice day here in Oklahoma City, for example. Okay, so now let's get to the threat levels for tomorrow. So Storm Prediction Center this afternoon, right around, actually when I finished my lunchtime live, about 20 minutes later, they came out with a new upgrade for Saturday. I talked about how they would go for a moderate risk in this area, and they might dip it down a little bit in this region. They went ahead and dipped it all the way down. So they're going to cover this part of the state in a moderate risk. And as always, don't get bogged down in, is your particular place, which color of the avocado are you in? As long as you're in the avocado, surrounding part of the avocado, that's all that matters. You've got severe weather expected in your area. Now we do factor in, let's go with the risk of tornadoes. That's this little graphic right here. It has a hatched area, 15 to 29%. Again, a hatched area is greater than a 10% probability of a strong to violent tornado, meaning that the Storm Prediction Center thinks that any storm that does form in this area that is supercellular, that does produce a tornado, does have a potential for it to be strong and or violent anywhere in this hashed area. So you can see it covers a lot of the big metropolitan areas. We'll look at the model data here in a second to see how that plays out. Down here in the Dallas-Fort Worth area, for example, it doesn't quite get you. It has it just to the west of town, the west side of Fort Worth, back out here to western Texas, probably because they think those storms will run into a cap and fizzle and diminish in your area. Now, we do have a cap across Oklahoma, believe it or not, as usual, and we're going to factor that into the forecast as well. Now, when I looked at the discussion from the Storm Prediction Center around 12:30, or just after 12:30 today, what's funny is this paragraph caught my attention right here, because this is what I described at lunchtime today. I think it was even yesterday I may even have mentioned about it, because the data had something a little peculiar in the surface mesoscale environment. So it said, aside from the steeper lapse rate environment near the dry line, mesoscale conditions will need to be closely monitored for low-level confluence lines within the deepening moist sector east of the dry line. The cap will not be particularly strong or high off the ground, aka low LFC, given mid-70 dew points, expected late initiation, probably after about 4 o'clock or so. This may be a plausible scenario from northwest Texas into central Oklahoma. The only reduced confidence in the total number of storm coverage is precluding a high risk at this time. So what you need to know is, typically when they go with these higher categories, slight, enhanced, moderate, it's supposed to mean you're going to have more severe weather reports as that category gets higher and higher. Now, if you only have a few storms, you really shouldn't go high risk, which is counterintuitive to what you're thinking. You're thinking, well, doesn't a high risk mean a high risk of big storms and tornadoes? Yes. So this is a very decided way to take a complicated probability distribution and give it to you in a graphical format. It is what it is. Take it with a grain of salt. The bottom line is, if you're in a color, pay attention. So here's a look at our colors again for Oklahoma. Strong, long track tornadoes are possible with the storms. The Weather Service is highlighting that important fact. Also, hail size up to softballs. That's some big hail. Maximum wind speed up to around 80 miles per hour. So the big red area covers most of the state here. And then as far as timing goes, out here in western Oklahoma, the earliest is 3 o'clock, but more likely probably closer to 5 o'clock. And that extends right here. And we'll look at the data here in a minute. Remember, the dry line is going to be probably somewhere out here or here. There's a little give and take in the model data. But there's a confluence line, like we talked about there from the Storm Prediction Center, that's kind of along a theta E axis, kind of in this zone, that may end up triggering thunderstorms down here that then move off. So necessarily not along the dry line, but maybe to the east of it. So again, that's the setup for tomorrow late afternoon. Now in Tulsa, they also have a risk of severe weather in that whole area, all the way down except for Fort Smith, McAllister, Atoka is kind of the bottom line where it goes from a slight to a marginal. But again, if you're in some colors, pay attention. Okay, so let's see here. I want to show you what the AI model did. For earlier today, it did have a kind of a central point of tornadoes right here in yellow across central Oklahoma, including Oklahoma City, the I-35 corridor, back down to looks like Lawton area. Otherwise, wind to the right, hail to the bottom left. And I don't think the new ones come in here this evening. Let me see if a current. Yeah, it has not. So that's from earlier this morning. These models kind of come in a little bit later than usual. Ironically, if you look at the analog data for the number of severe weather reports we get in a similar situation, I want to show you how most of the reports are here. Very few reports are here at all. I found that quite interesting. So when it goes back to compare similar events, it doesn't have any storms here in Oklahoma. So probably in those prior events, the cap was too much of a factor and it kept them at bay. That's my thought. If you look at the tornado probability in considering past events, it does, though, have us included here in the western 2/3 of the state for tomorrow. So we still are under that specific region. If you do look at the other Nowcast AI model, it also favors that region from 44 up to 35, and then central Oklahoma, then back out here into Kansas and Missouri. So those folks up there, you also need to be paying well close attention. The upper levels of the atmosphere, we have our little disturbance, which zips through Four Corners region right here. And we have our little wave of instability that's kicking out ahead of it. So these bright colors right here you see streaming in a southwest flow indicates lift in the atmosphere. And as you go more south, the lift is more subtle, not as what we call brute forcing. Whereas when you go closer up here to the core, you get a little bit more brute forcing because the lift is much stronger. In other words, it's much easier to break a cap. Here, we're kind of on that trailing end where we have a cap that will hold a little bit, but we'll probably break it in a couple of places. And then as you get further south, too far south down here, then you get no lift, and so therefore the cap holds. Let's see. Let's take a look here at 700 millibars. There's kind of a highlight here of the dry line getting a lot of lift along with it, and maybe some dry line shift also gets enough lift to get some storms to go. If you look at just the generic, what we call a classic setup, when you're looking for dynamics for thunderstorm environments of where you're going to get severe weather, you're looking at the position of the jet stream. This is 300 millibars, so basically it flows right over us. So we have a good position of the upper level jet stream. If we look at the 500 millibar level, this also indicates where you have a speed max, or just basically the winds in the below the jet stream level that we're looking at it. Even at the mid levels of the atmosphere are still quite strong, and these are up around 50 to 60 plus knots. So that also helps aid in storm development. If you then look at the low-level jet area for around 850 millibars, low-level jet kicks in right around between the 6 and 7 o'clock hours. The sun starts to set. Then it really gets to cranking really between 7 and 9. This also shows that favorable environment. We're going to have quite a bit of wind filling in from south to north, and you do have a convergence axis right here into west central Oklahoma for any storm to take advantage of here at the 7 o'clock hour, 6 to 7 o'clock hour. Now, when we look at what we call our significant tornado parameter, this is where it kind of factors in a lot of ingredients in the atmosphere to show you where it thinks the best coverage zone is for tornadoes. So if you look at the HRRR, we're going to focus our forecasts. Believe it or not, I'm going to give the HRRR a little bit more leeway than I normally do. In other words, I'm actually going to lean more toward it this time around, because let me tell you, the HRRR stinks this year. It has been horrible, despite what you may have heard. We use this all the stuff, look at all this, the data and the parameters. And the problem is because the HRRR has a huge bias of over-mixing. It mixes too much of the moisture out along the lower levels and dries it out too much. And therefore, it doesn't produce storms like it should, or it's in the wrong position. So the HRRR has a known bias that stinks, and they can't fix it. So it is what it is. So no, it hasn't been doing well at all, because it's messed up the surface environment. Like, believe it or not, the 3-kilometer NAM has been golden almost every event here this year. So that's been my pick of the litter. We'll see what tomorrow looks like. But regardless, here is the HRRR environment for tomorrow. I'm just going to kind of show you what potentially is on the table. You can cherry pick this spot, just kind of give you an idea of what it looks like. Now, on that particular case, we look at the holograph, which is nice and smooth, sickle shape, so to speak. We have a nice little slinky box, typical classic supercell box. Potential hazard type, tornado, checked. Shear goes from a southeast direction to a southwesterly direction quite quickly, below 3 kilometers. Nice directional turn as well, and the speed shear, anywhere from basically 25 knots up to around 55 knots. And then all the winds upstairs are all uniform and strong, so we shouldn't have any problem with the storms collapsing or getting messy. They should be pretty classic supercells. Now, here's the kicker. Temperature forecast at this particular point is about 86 degrees. It's about 7 o'clock, so in other words, it should be a couple of degrees warmer than that, so it probably right around 90. I didn't look at the models for the high, but it should be close to that. However, the convective temperature is 93, so technically that means the cap holds and we don't get any storms. So you're going to have to fire off storms, send some other area than here in Oklahoma City, which is, I think, is where I randomly picked, just to show you the environment at 7 o'clock. Yeah, let's see. I picked in El Reno, so I picked just west of El Reno. So that's just to give you an idea what the environment has to work with. But if you go out here in this area, the cap is going to be weaker, and we have that confluence lines. Therefore, that's the spot where storms are likely to go. But look at these other models, like the Nestle. They're all when they're not storm contaminated. In other words, they don't have any storms that have already developed on the map. They fill the colors in quite nicely. And a lot of this is depending on moisture. So some of these models are not quite capturing the low-level moisture properly. So some of them are a little lower. And then a lot of them just kind of are moved around in different places as well, depending on how far that deeper moisture goes. So if you notice, Kansas up here didn't have a whole lot of those colors up there. And that's a little bit different. A lot of the models don't put deep moisture into Kansas. Therefore, they don't give the best, strongest tornado dynamics into that area either. But let's take a look here at Oklahoma. So 3-kilometer dam has pretty much most of the entire state, all in these areas where you have Cape values between 4,000 and 5,000 joules. Where you have these little triangles, right? Indicates widespread shear, 9 degrees of turning, and that's supercells love 9 degrees. If supercells can get 100 degrees or 120 degrees, boy, they're singing. They're so happy because what they need, they want to rotate really bad. If you have these wind shear vectors, let me see, something like this, where it's all southwesterly, and between all of them, it's about a 5 degree of turning. that's a no-go. There's no storms going on in that environment. It's not good for shear. But if you have this little triangle approach on the map, that's what the storms like to see. If you look at the HRRR, it kind of focuses what looks like a theta E axis built in to the Cape values that shoot up in this zone of convergence. And if you do, let's see, I think this is about Anadarko. Just kind of get an idea what it looks like out there. It's a very similar photograph. By the way, the effective significant tornado parameter is up around a 10, which is about doesn't go much higher. Most of the charts will stop right about 9 or 10. This one caps, it looks like, at about 11. And I've seen this little bar go off the chart. This just indicates that it thinks parameter's good for a violent tornado tomorrow. Violent meaning EF4 and EF5. Strong tornadoes are typically EF2 and EF3, and then the weaker tornadoes are EF0 and EF1. Wind damage rating is a 2.6. That means Elijah's going to have some big wind with him. SHIP model is for hail. It says 4.5. You only need a 2 for hail sizes bigger than 2 inches, so therefore you got grapefruits there in the future. And of course, not all storms going to have grapefruits, and not the whole part of the storm doesn't either. It's just the unlucky small areas that do get those biggest stones. Everything else is usually a lot smaller. However, still destructive because we're going to have big hail tomorrow in general. All right, let's see. Cape values, like we mentioned, up around close to 6,000 for the most unstable. And if we actually hit that convective temperature, which, that's in the low 90s out here. So that's pretty close. That means there's going to be heck amount of instability in the atmosphere to work with, heck amount of shear. I'm telling you, this is textbook for supercells that produce damaging tornadoes. So a lot of the storm chasers are going to be really excited. Just let you know, they're going to be jumping up and down. This type of a setup is a very classic setup, and it usually produces. Let's take a look here at the HRRR. This is a dew point map like I talked about. So here's Oklahoma City, a dew point here at 7 o'clock around 72 degrees. Down here in southern Oklahoma, it looks like it's in the mid-70s. Now, I will warn you, these dew point values could be a little on the low side. They actually should be quite a bit higher. So I think we may probably have dew points here in the mid-70s. And anytime you get dew points mid-upper 70s, you're in trouble anyway, just more fuel to the fire for the storms. But we can see here we have the brown, by the way, is where you have bone-dry atmosphere. It's a 19-degree dew point. So you can tell even from the HRRR, it's trying to put the dry line somewhere about here. All right. But if you do notice, we have a nice southeasterly wind here. And we kind of have a wavering wind kind of in this area. It kind of just goes up here in different directions. These are all southeast. So what we end up being is a little bit of that confluence zone in here. That's going to be a larger area to help spawn some thunderstorms versus just right along the dry line or something out in this region. So in other words, they should develop much closer to central Oklahoma versus what they usually do. They usually form out here in the state line. We watch them forever. They come out this way. By the time they get here, it's 9 or 10 o'clock or even 11. Then they fall apart. This time around, they'll probably end up forming here. And all of a sudden now, they're right in your backyard an hour later, and now you got to deal with them. And that's usually when they're the strongest. Okay, so just kind of give you a heads up on the moisture train. Other models, by the way, if I go through here, they all are a little different. They move that dry line east and west. For once, I don't like the NAM's output. I think it's way overdone. The dry line is way back here. It does have that little zone that we talked about where you have a little theta E axis and some moisture, but the surface parameter is quite a bit different. Let's see. And that's about it. All right, let's go on into temperatures. So tomorrow, again, according to the HRRR, and it's going to dry things out a little bit, so it's trying to get us here into the upper 80s, and I think that's doable here in Oklahoma City. But it's got here the low 90s, and it's these low 90s in this region, these little peppered 90s that come in here, all the way down here to mid 90s, to here's upper 90s, is what's going to help to break that cap. And models actually form storms really down here in this region, because it also breaks the cap down here around the Wichita Falls area and points south and west, is reading climb up to around the upper 90s. So you're going to have to be a hot day tomorrow just to brute force break the cap. All right, now, what is the cap? Well, it's a layer of temperatures aloft in the atmosphere. And the temperatures upstairs at that layer is too warm. It's a capping layer. It's an inversion layer. So it's too warm. It has to be cool for a storm just to develop and just go right up. But if it's warm, it's like taking your heat pan, holding something down. It's not gonna get up. Your fry pan, your heat pan. I call it a heat pan, sure, why not? Anyway, so here's a look at the sin values, the cap values. Where you see the brighter colors, the stronger the sin. So over in this area, where you see purple, this is off the chart strong, all right? But where you see basically gray or white, which is a good area here in Kansas, and the good area here in Kansas, and also, if you notice, a good much of western half of Oklahoma, that's your CAPE values are either almost non-existent or at the very easily breakable period where they're about less than minus 25. Joules per kilogram. So therefore they should be able to break the cap in a few areas with no problems. All right, just want to show you that the experimental models that we use for ensemble outputs, they don't, or let's just say they're having trouble with tomorrow as well. So like for example, here's tomorrow 7 o'clock. Okay, so there's one storm there in North Texas. Here's one. Now it's got a couple of storms, but there are 3 storms in southern Oklahoma. Here's one. It's got some in North Texas, southern Oklahoma, and northern Oklahoma. Here's one that says, nope, cap holds everywhere. Nothing's going to happen. And then here's the one that says, well, let me just put storms everywhere for southern Kansas, northern Oklahoma, and in southern Oklahoma, but not much in between. All right, so that model is actually pretty active. When you try to use a little artificial intelligence, etc., this one says dry, 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 dry. Oh, we got one. It's got storms up and down I-35. Stuff in Kansas, and more in Kansas, and more in Kansas. So this model, only other than 1 out of 10 members, only 1 will give you some tornadoes. If you do look at the HER that we look at oftentimes, let me see, this is probably from today. Yeah, okay. Let's see, probability 2, and you look at tornado. Okay, so if you look at the probability of seeing a tornado within 120 kilometers, the HER is off the charts. This model, either it is going to be a grand slam home run to say, hey, I apologize for stinking all season. I'm going to nail it tomorrow. And by doing so, that means watch out, because you have a 90 to 6% probability of seeing a tornado here in central Oklahoma and around this particular case, 120 kilometers. Now, if I reduce that to 40 kilometers, which is obviously a little smaller, you have a 35% probability here in central Oklahoma, also east central Kansas, and even into Missouri. Take home here is that in this area, we're watching for the potential for tornadoes. That's basically all that means. If you do look at the WRF, and I like the WRF a lot, it sides with kind of one of those ensemble ideas that we saw, but kind of a mixed bag of them, which means a lot of storms here in Kansas. These are all helicity tracks, which are hail, wind, and potential tornadoes. And then you have down here, which is the same thing, hail, wind, and potential tornadoes. But if you notice, nothing in between. Now this model in the past, let's see, let's zip this one out. Yeah, because that's going to be the past run, I believe. No, so this right here is the past run, okay? And then the past run, it kind of had a few storms up here in northern Oklahoma. Kept those ones down along North Texas and far southern Oklahoma, but nothing in between. And then there's northeastern Oklahoma, and there's the Dallas-Fort Worth one, the Rockwall area, and then you got Kansas again. So this model had favored almost a continuation. 1, 2, 3, kind of a little skip in between, and some of those kept going. And then, like I said, today's run, the new version of it that came out, just basically erased almost everything in the state and just kept along the Red River, and that was it. This is a sign that this model is struggling with the cap. It goes from having a weak cap to having a stronger cap. So that is going to be a factor tomorrow, and no one will know whether that cap completely holds or doesn't hold anywhere. My guess is, because we always look at these numbers, and everybody looks at the same numbers, my guess is that the cap does break in just a few areas, and therefore we get these isolated supercells. The problem is these models aren't good to tell you exactly where. Let's look at the 3-kilometer NAM. So here we go. It fires off some storms here in the eastern Texas Panhandle because of the dry lines way out west in its data. But it also fires off storms in this other little area we focused on. And let's see, there's 7 o'clock, 8 o'clock, 9 o'clock, and 10 o'clock. And but these weaken quite a bit because, again, the cap is strong and it gets only stronger after 9 o'clock, and therefore these storms start to evaporate pretty quickly, and that's according to a 3 kilometer NAM. And honestly, most seasons it's been spot on. Sorry, most seasons. Most years for sure, but this year, most events has pretty much been an outlier as far as being the best. That track record is usually not that good, but it's just the other ones have just been so bad. Okay, let's take a look at the HER. Now the HER, let me show you what the midday run did. Oh, go back. And we're almost done. We got one more map to show you. So let's see here. Here we go. All right, so this is the run from noon today. It had 2 supercells just pop up right here in central Oklahoma. Of course, look where they're located, obviously, over densely populated areas. There's 8 o'clock, moving through the north side of Oklahoma City to Edmond, Stillwater, to Ponca City to Enid. And at 9 o'clock, that one moves east on the turnpike, Creek County, heading up toward Tulsa from 9 to 10. And you have those other storms that move into Kansas. And then at 10 o'clock, more storms there in southeastern Kansas. This little storm here kind of moves more to the right on the south end of Tulsa, heading over to Muskogee at 11 p.m. And that thing moves eastward to midnight, and then by 1 a.m. Is now into Arkansas and pretty much dying out. So in this particular case, with this look, this model favors tornado-producing environment despite the cap, but it also has a weaker cap than the other one did. The other one, just so you know, is typically much better at estimating the cap strength than this one. But we shall see, because this model was built with this in mind. In other words, they wanted to see the best supercell model they could get that could also still do other weather well, and so it was built with that bias in mind. So in other words, it probably loves perfect environments where just a cap is all it has to deal with, and that's probably where it excels, where it succeeds. So now if we look at the new version of it that came out here just a few minutes ago, or about an hour ago, you notice supercells are now breaking out. Still that kind of that same signal here for us, but then it drops quite a bit more all the way down into Wichita Falls. If you look at the next hour, look how they just erupt. Then you have supercells up and down, again from central Kansas all the way down through Oklahoma into far northern Texas as well. And there's 9 o'clock that keep those tornado-producing storms going. And there's 10 o'clock, still more up there in Kansas, still more here in eastern Oklahoma. And through 11 o'clock, that stuff starts to fizzle around the Tulsa area. And in McAllister, looks like that one storm still hanging on just south of you by midnight, and then it's gone. And those storms in Kansas still continue for another couple of hours, and then they're gone. So obviously it's a little bit different look. It's a little more ominous, because going back here, it's probably overdone. I would cut out, if I were to be more practical, I'd cut out this one, cut out that one. The point being not the specific exact cells, but to show you that there should be more breaks and less congestion, all right? And unfortunately, that's not a good thing. You want a lot of congestion to mess up tornadogenesis. All right, let me just look at a couple of these others that we have to kind of give you an idea what they were thinking. These are our CAM models. This was what I always had called the supercell model in the past, because if you gave it a chance, it produced supercells any day of the week. It actually still does for tomorrow, both in western Oklahoma and down south into Texas, but still kind of favors that northward jog and also down south, and not much in between. So it may mean that, again, those storms struggle due to the cap strength. Let's see here. Let's go to the Nestle. I like this one. All right, so the Nestle idea also loves northwest Texas, far southern Oklahoma. As it comes into central Oklahoma, it fizzles because it kind of starts early. These things are right around 4 o'clock hour. There's 5 and 6 o'clock. There's stuff now at western Oklahoma on the dry line. Same idea, that kind of moves north. We got to miss out. We kind of split the difference. We don't get anything down in central Oklahoma. Now, I'm totally fine with that. I'm totally fine with the cap holding the whole thing. It's a big bust. I won't complain that at all. All right, let me see. I think really that's all I wanted to see on that deal. The wrap will be good in these environments because it does pretty well for cap strength. And the prior data I'd seen, let's go to this one. All right, so it has your signal here of storms trying to go as early as about 4 o'clock to 5 o'clock, and it kind of favors this zone, which is what a lot of the models did actually. So that's probably going to be starting things here in this circled zone for tomorrow afternoon after 4 o'clock. Now the difference is this particular one, that first one that went up, he died almost immediately the next hour. Now that tells me the cap's too strong up here for that particular hour that it went through, and it likes this area better, probably because it got much hotter, broke the cap quite easily, and then this would be the beginning stages of storms, and that would march in this direction. And then of course we'll see how things build up in this spot too, if the cap holds or breaks up here, which it should, and form more storms from Kansas into Oklahoma. All right, your temperatures, so will be, like I said, close to 90 tomorrow. Here in Oklahoma City, again, it depends on which model you're looking at, but most of them have about 92 or 93 to break the cap, so we're not that far. Sunday, 91, and then we're into the 80s after that. I see a trend here, trying to get these numbers down a little bit. Otherwise, pretty decent stuff for May, pretty standard, all that kind of stuff. So that was what I had here for you. So in short answer is yes, we're going to have a few thunderstorms. Yes, they're going to be more isolated, which means most of us, seriously, if you do a percentage on that thing, it's probably like 85, 90% of the state won't get a drop of rain, but that 15%, it's going to be, brutal. So you don't want to be in the 15. But the point being is that just with all the conditions around, it's one of those classic late May events where shear is great, instability is great, everything else is there. You have a cap, but it's not too strong, but is it strong enough? Because what happens is there's a balance. If it's too strong, you get absolutely nothing. If it's too weak, you get storms that bubble up everywhere, and they run all over one another, and they end up lining out probably to a squall line, and then it just messes up the environment. So you get very few tornadoes as a result compared to what you could have had. So what happens then when it's moderate and come to weak, so it's breakable in a few areas, you get a couple of storms that go up. So I think this is your dry line, for example. Maybe you get a storm that goes here, and you get a storm that goes here, where it gets weak, but not in between. So it just separates them quite a bit. A lot more space between them, so nothing can interfere and interact as it need to mess things up. So that means those storms, the supercells, would be much easier to produce tornadoes. So tomorrow it should be a day where they have no problems going from nothing to storm, severe storm in 30 minutes, and between 30 minutes and an hour probably producing a tornado already. So it should be happening pretty quick in this environment. So we will have tornadoes across state. They will be, the ones that do develop will be strong to possibly even violent. There's a potential to be long track. Just depends on how things go with things called cold pools and precipitation shedding and all the stuff that happens when you get these big beastie storms, and if they're nice and clean or if they're a little messy with something not predicted quite well in the atmosphere for the wind that messes up the storm structure. There's a lot of things that can happen. Trust me, it is very hard to get a tornado. You have to have perfect conditions, and we rarely have perfect conditions. So that's why you don't get them every month, every year, every week, because it's not. Any severe storm that goes up, there's so many things that has to happen for it to even get to that point. That's like the last stage of the storm. So to get there, it's like moving a mountain. But it does happen, but you have to things look good, and tomorrow they will look good for that. So it's one of those rare days. It reminds me of the event we were supposed to have. I was on a Saturday, or was it Sunday? I can't remember now. I think it was Saturday. Yeah, so it was a Barnsdall tornado, right? And we watched that little pseudo squall line develop in northwest Oklahoma that kind of traveled east just north of 40 and just produces some wind and hail on the way, only in some little mini rotation areas. But it was never the event that was supposed to be. In other words, it was supposed to be supercells breaking out just from random anywhere places. The cap was non-existent, and everything else was there. The violent or the significant tornado parameter was off the charts as well. So tomorrow evening looks a lot like that situation in the data. Now they're not identical, just a lot of similarities. In other words, there's enough to where you're really concerned that you do get some of these big storms, and they're being shown in the data very close to around big metropolitan areas is bound to happen. So we haven't had to deal with an EF4 or EF5 anywhere near central Oklahoma in a while. So, and tomorrow may be the day that kind of is. I mean, it may be one of those deals we have those violent tornadoes, and hopefully not overpopulated areas like last night. That thing was on the ground for almost an hour, and it was in various stages of it, and it hit the most perfect, moved around that spot of the state as best it could to be over farmland and just do a bunch of shrub brush damage and trees and stuff like that. There were only I think a couple of farmhouses in the way. I know there was a little minor damage I think I saw in one, but you'd rather have that outcome than you would obviously over into a big city like anywhere in the metro of Oklahoma City or Tulsa, etc., or Lawton, just all these really big cities where there's just a lot of land. So even though the supercells are quite small comparatively speaking, that's a lot of structure in a very larger area. So it's much easier to target somewhere, and we can't tell you where. In other words, the models aren't that good this far out. If you're wanting to know more specific on a track, if you're going to be hit by let's just say, for example, my wife asked me this because she's from Canada. She doesn't know. So I told her there's going to be tornadoes tomorrow. Her first question is, here? I'm like, yeah, here. She goes, no, at the house. And I'm like, no, I can't. No, nobody can tell you that. It's not like that. But that's a valid question that anyone wants to know, right? What about my house? Because that's what I'm here for. So all we can do on the science side is narrow it down to, let's say, like small sectors, like a few counties, like grouping a few counties. So, for example, grouping central Oklahoma tomorrow, where I think a tornadic storm will go through. The answer is yes. If you saw all the model data we looked at, the only way that will not happen is if the cap is just too strong and nothing can move through that area and hold together. That's it. So it's either going to be a yes or a no. There's no 50-50 on that deal. So once we get to the day of an event, so like the morning of, all the data's in, all the model data's in, our best short-term models are in, all that kind of stuff. We can sample the environment better and the storm better. In that particular case, a lot of times you can keep that hyper-local zone for predicting where tornadoes will occur, because you can look at surface features like triple points and dryline bulges that are all favored for that kind of activity. And you can maximize where the shear is in different pockets. So you can overlay all that kind of stuff and predict where you think the most possible area for tornadoes will be. All right, then as the event unfolds, and then you finally get the storms that are developing and how they look structurally and how they're currently moving and what you expect them to do as they go through a strengthening evolution. So a lot of times they'll move from a certain direction and then they'll kind of veer to the right, to the east, as they turn to the right and rotate more. So that kind of can change that direction off a little bit. But given those two worked out, you can get a time of arrival, for that storm easily up to 3 hours, 2 to 3 hours. It's just if they move around too much, that reduces the accuracy of that. Now, as far as tracking the actual tornado itself, just know that in any path that storm goes, the only spot that's worried about a tornado is on that far southwestern fringe where the hook is. So again, you could have this whole section of a storm go over in a large area, but only one little tornado is way down here, and it's just very tiny, so it doesn't hardly affect anybody compared to the rest of that storm. So in that particular case, though, when you're saying, will the tornado hit my house? Well, that is when you have to take a smaller window, like a 1 hour window, because you can track them as a cyclone and assume a steady state equilibrium condition, which is a big assumption, but let's just say we do. That's about up to an hour, and if that mesocyclone path is coming over toward your house, well, that's where the tornado generates from. So at the time, it's not a guarantee that you'll have a tornado at that point, but what we'll tell you is that you're going to be under where that mesocyclone should be, and that was where either a new one will form or one that had formed, and that's what's left over of it, or one's already ongoing. Idea is the same. And then as those radars get lower, sampling of the storm, so in other words, we're not hitting that storm in the mid-levels of the atmosphere, but we're way down low. I mean, we're talking super low. I like to be under 1,000 feet when I'm tracking street by street corner, here like in the metro, for example. That way that we have the best accuracy and position on the maps. So in that particular case, and we're talking street by street, so we're telling you where it is, we're factoring in the movements, and then we'll tell you, okay, it'll now be at this intersection, and then this intersection, and then this intersection. So now we're talking about, is it going to be at my house? Well, at that particular time, you're talking a warning, as we speak, like a nowcast warning, to where, okay, I'm telling you in real time, and by me telling you in real time, depending on the speed of that storm, what I'm telling you is it can be 5 minutes, it can be 15 minutes, It can be 1 minute. I mean, if the storm's just moving really fast. Now, most of the time they don't here in Oklahoma. They're slower movers. So yeah, that can end up being several minutes of warning. So that's how you can really answer that question. So if my wife came and said, hey, there's this guy AT, he's got a storm. He said there's a tornado at this intersection, and it's going to be at this intersection next, and then he's coming up to this intersection. Are we going to hit by the tornado? My answer would be, heck yes. Let's get under the shelter. So that's how you can look at that. So for people that are new, don't know much about tornadoes, how that works, that's the whole process of basically what you're hearing as a tornado warning. If somebody says we're under tornado watch, that just means conditions are favorable. That's all that means. It doesn't mean you're going to be guaranteed a tornado. It just means watch out for big storms today, because if they do, they have the potential to produce a tornado. So that's just the difference between the watch and the warning. So that was another thing I just kind of want to touch base on for the newcomers, or those that just need a little refresher, just didn't know. Lived here the whole life and no one told them. Well, now you know. Let's see, as far as protection goes, I will be broadcasting live. We'll probably do a live around lunchtime-ish, so somewhere in that vicinity. My lunchtime on Saturday is a little different than yours, I'm sure. I don't know when it's going to be, but I'll do that. And then, so then we'll try to narrow down a more specific area where I think tornadic storms will be. And then we will start broadcasting live probably 5 o'clock in the afternoon, somewhere around about that time as the storms do get going. And once it looks like they're getting into that phase that they could produce a tornado, that's when I'll jump on. Otherwise, I don't typically cover just the wind and hail. That only happens if the tornado threat has ceased for a minute and we're waiting for something to regenerate, and it's just a severe storm at that time. I'll stick around for that. It kind of just depends. It's all fluid, but I usually do cover for tornadoes. All right. Other than that, use my weather app. It's free. It's called AT's Weather to Go. If you go to Apple and Google Play right after this broadcast, you can just search for Aaron Tuttle or AT's Weather. It'll all pop up. Just make sure it says AT's Weather in the logo, because what people will do that have other weather apps, they use my name as keywords so that it would search, and they pay, and they do a lot of things, tricky things, to get you to pick the wrong one. So it's just look for ATS. All right, I think that's about it for me. Let me look at a couple of your questions, and then I'm going to bail here very quickly. Just make sure that I didn't miss anything. And I'm sure most people are probably, the question, $1 million question is, what about my house and all that kind of stuff? And so I get it. Everybody wants to know. And the best I can tell you for right now is, if you're in Oklahoma City, surrounding areas, you got to pay attention up and down I-35 to the west in west central Oklahoma. So that's right now where I have the corridor. And then I'm expecting at least probably 3 supercells within that corridor. And then we'll kind of go from there. So, it's not a widespread event, but it is going to be a significant event for any of those storms that do go up. Anyway, so if you did have a very, very important question, fired off real quick here at the end on Facebook and YouTube, because I won't have time to go back and read everything else. Let's see. So on Rumble, there was a cloud seeding question. So cloud seeding's been going on forever, just so you guys know. I'm not going to get into the whole chemtrail, comtrail, cloud seeding conspiracy. I don't get time for that. What I'm just telling you right now is that cloud seeding's been done. Soon they figure out ways to do it, because they got to try to make it rain in these desert areas, the drought-stricken areas. So that was the purpose of that. And unfortunately, it's like 50-50. They really can't prove it works well enough to not do it, but yet they can't not prove that it doesn't. So it's worth it. The cost is low enough to where just do it anyway and see if we can get a little extra rain out of it. So other than that, I wouldn't worry about it, because it's too weak of a factor and too micro used, too small of an area. Timeline for tomorrow is after 5 o'clock, it looks like. 2 areas of initiation, dry line across western Oklahoma. Actually, I guess 3 technically. And then a convergence line that's east of the dry line, so more maybe like around Weatherford, north and south from there, 81 or something, so they're not way out in western Oklahoma. Then the third area is down into Wichita Falls, south there in northwest Texas. So those 3 places are most likely to fire off up around 5 o'clock, and of course then they'll move to the east and northeast. Let's see. So Springfield, I didn't look at anything for Sunday long. I just kind of focused on Saturday. But everything usually shifts east a little bit, so you're going to be in the path. 'Cause I know eastern Well, you might just be past W because might just be in Arkansas at that point because it's all Arkansas in the eastern third of Oklahoma for Sunday, and it's a lot less of intense, significant parameters. So there'll be a lower end severe storms versus the upper end like we're going to be dealing with tomorrow. Let's see. Somebody's asking for Larry. You guys always ask for Larry. Man, I feel bad. Little Larry had some teeth pulled again. I don't know if you know about Larry. He lost some teeth like 2 years ago. He just started. I'm like, "What are you chewing on, buddy?" He was, "Oh, just my tooth." I'm like, "Well, how'd that happen?" So turns out Yorkie. He's one of the Yorkies that I was on the bad end of being a Yorkie, where your teeth just don't want to stay there. So, and of course, if you try to brush your teeth, they bite you. And I was like, this is pointless. So, yeah, he lost a few more. I think they lost 5. They took 5 out. He couldn't afford to lose any, but they took 5 out. And that's 5 in addition to... How many, Jody? No, it was the first time. Well, I know. You could bring Larry and count his teeth. But, no, the first time I think he had 20 teeth pulled or something. I don't know. How many teeth did they have? Oh, my gosh. Anyway, he had a lot of teeth pulled. And, man, he was hurting. This time around, he actually cried. He never cries. I got home, and he sat there and just cried. I'm like, oh, he tore me up. I said, I'm sorry, little buddy. We'll get you some more pain pills. Oh, now he still smiles with half his teeth. Still looks cute, but, man, I don't know what we're going to do with him. But he's, how was he, 5? 6? I can't remember. Let's see. Then real quick, on Facebook, somebody asked me one more thing. I missed it. Oh, our last event for tornado season. Matt wants to know. I can just tell you in the short term, meaning within the next week, there's nothing on the horizon anywhere, anything that's like what we just dealt with or what we'll be dealing with for tomorrow. So as far as big events, the way it looks on paper, no, I think that's probably about it. Normally, we cut that off like a hard line of sand here in Oklahoma at the end of May. We still linger into June for a couple of weeks, but it kind of transitions over to more of a squall line deal that comes in more late at night or early morning. So we get less and less of a tornado threat. We still keep a few, but it's really strange how quickly everything just kind of tapers off. All right, I think that's it. I'm going to get out of here. Susan, I looked at the new NAM when we first started the show. It's cute, though. I do like when people ask, I want to hear this computer model, that computer model. That would have never been spoken or done of 5 years ago. And here we are today. Hey, what did the her say? What did this say? It's pretty funny. I know there's no problems with radars last night. I don't know what you mean by that. They probably saw ground clutter patterns or interference patterns. Who never knows? There's always stuff on radars that happen in the atmosphere. So if anything you see on the internet that says beams, radar beams, like I caught them, like they're controlling the weather, they're doing laser stuff, all that, whatever it is block the person. Mute them. No, because it's normal stuff. It's all from various different reasons, and I work on all of them, so I can assure you, as the person that's involved, that's all it is. We're not shooting at stuff to control the weather. These are receivers for rain. All right. You did talking about helicity tracks yesterday. Yeah, they're about that. See, helicity tracks. Who can even spell helicity? I don't know. We might have trouble with that one. But yeah, helicity tracks. You want to know where those are at because those have the tornadoes in them. You don't want to be in a helicity track. That's for sure. Never want to be in a helicity track. I've been in a helicity track. Steve Crono was in a helicity track. We were the same one together. I was upstairs. He was downstairs. That was one of the glory days of storm chasing. All right. Let me think. I know you guys are calling for Larry and Penelope. Maybe next time, because remember they're still a little not 100% from the deal. Penelope bounced back much faster. Larry, I think, still kind of milking it today. But he didn't lose most of his teeth, so I don't blame him. He's got a little right to do that, right? But I think I showed Penelope, was it last night or yesterday, lunchtime? I can't remember. Or was it today at lunch? Honestly, I don't even know what day it is. Welcome to my world. That's why I started this broadcast saying Happy Saturday. I don't know what day it is ever. All right, that's it for me. I will see you guys around lunchtime tomorrow. Look at the new data from the morning, and we'll see if that kappa is going to hold or not. And if it looks like it's going to break pretty easily, what time that would be, and if it's going to hold, then that means everybody gets to enjoy a nice, quiet Saturday evening, as you probably already had planned, and go from there. All right, I'm going to get out of here. You guys have a great night, and we will see you tomorrow. Take care.